Hello, dear authors and invited guests. Very good evening to all. Welcome to technical session 6B. This, on behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 6th International Conference on Information and Communication Technology for Competitive Strategies, in concurrent with 6th International Conference on Smart Transfer Computing and Communication through Zoom. We are thankful to everyone who present on this platform to go along with us digitally in these unpredictable circumstances of COVID-19 and making this conference more productive. Also, we wish everyone and their families a protected time. We all together pass this soon. Just before we get started, I would like to introduce you all to a chair for this session. Chaya Jadhav. Chaya Jadhav, Dr. Chaya Jadhav working at Dr. D.Y. Patel Institute of Technology, Pimpari, Pune since 2001. Presently, she is working as an associate professor in Department of Computer Engineering. Total teaching experience is more than 25 years. Currently, she is doing research in the field of medical image processing and machine learning. Presently, chairman for new syllabus farming for digital electronics and logic design under Savitribai Phule, Pune University. She is approved PG teacher by Savitribai Phule, Pune University, and working as a subject chairman, paper setter, and senior supervisor. She guided more than 10 PG student and UG project. Further, she also enthusiastically participated in various activities associated with Pune University. Thank you, ma'am. So shall we start with the first paper?
Yes.
Our first. Also, there is a special note for presenters. It will be 8 minutes for presentation and 2 minutes for question answer. On 7 minutes, I will use a gentle reminder. So everyone can mute it while the presentation is going on. Thank you. Our first presenter is Kanchana Rajaram. Our paper title is CCC Quality Cross Cloud Service Composition based on quality of clouds and web service for business application. Kanchana, are you there?
Good evening.
Good evening.
Good
Yes,
evening,
you
madam.
can.
Shall I
Yes, you can start.
share my
Yes.
presentation?
Yes.
Yes.
Is it visible?
Yes, you can start.
Yes.
My presentation is full screen or should I?
No.
It is not full screen?
No.
You can start.
Yeah. So, good evening. Our paper is cross-cloud service composition based on quality of clouds and web services for business application. And my co-author is my student Preeti Navina. I am from SSM College of Engineering in Chennai. So in this presentation, I will be outlining the architecture of our proposed work, the experimentation and results from this work. And then finally, I will compare our work with the related work. Actually, the motivation for this work and the problem, composition of web services, it is a requirement when a single services alone cannot satisfy the requirements of the user. So when we are combining more than one service, normally nowadays the services are deployed in cloud platforms, and whatever service we require may not be available in a single cloud. They may be available in multiple cloud platforms. And to satisfy the requirement, we may have to combine or compose the services from different cloud environments. Yeah, while composing services, we need to consider the quality of the services. First of all, the functionality must be matching, but for satisfying the same requirement, that is with the same functionality, several services may be available in a particular cloud, or several services may be available across the clouds. Now, we have to consider the quality of service in one N. Also, the quality of cloud platforms. None of the existing services, they consider the quality of cloud platforms. There are many papers in the existing literature for QoS or quality aware composition of services, but none of the services consider the quality of cloud platforms. That's why the objective of our work is to consider the quality of web services as well as the quality of cloud platforms to increase the satisfaction level of the user. This is the objective. This is the architecture of our system. Here we are actually going for dynamic web service composition. Means the requirements are given at runtime, and depending on the workflow of the solution, we will be composing the services required one by one. So we have a client who gives the request, and the services are selected from the registry. Registry is a pool of services. So we'll select the services which are functionally matching with the requirement of the user. And it requires, we are assuming that more than one service is required to satisfy the requirement. And now the services are available in multiple clouds. That's our assumption. Now, based on the QoS of the services and QoS of the clouds of the similar functional services, we are trying to select using the service composer. While selecting the services, we are making use of something called utility function. This utility function is Qmax minus Qx by Qmax minus Qmin. The concept here is we may want to minimize the cost. We may want to maximize the reliability. So, based on whether we want to minimize or maximize, this is Qmax minus Qx or Qx minus Qmin. The denominator is same, Qmax minus Qmin. That is the maximum and minimum quality. And what is Ux? It is the utility function. And now, because we are selecting the web services based on many QoS parameters, we assign a weightage, because not all the quality parameters have the same weightage. So we are considering 3 quality parameters for quality of service, namely security, not there, security, cost, and response time. So we assign 60% weightage for security, 20% weightage for cost, and 20% weightage for response time. Similarly, from cloud platform, we consider 2 quality of service parameters: CPU utilization and network utilization. CPU utilization, we
dear presenter, your last 1 minute.
Okay. CPU utilization, we consider 60% weightage. Network utilization, we consider 40% weightage. So once we select the utilities for individual QoS, we multiply it with the weight. That is, we are taking the weighted sum, and that will be total utility function of a service. So this is actually normalized to 0 to 1, towards 0 less satisfaction, towards 1 more satisfaction for the user. And because the composition is done dynamically, the steps involved for QoS service selection is the weightage for the QoS of service is obtained from the user. The utility function using the above formula is calculated, and weightage for each QoS of cloud is also obtained from the user, and the utility function for cloud is also similarly calculated. Now, the weightage for service QoS and cloud QoS. Actually, we are assuming that equal weightage, 50% weightage for QoS of the web services, 50% weightage for the QoS of cloud platforms. So again, the combined utility for the services and cloud, it's calculated using this second formula, U of S. So once we calculate combined utility, the service with for many services functionally satisfying our requirement, this we are calculating. And now the service with the highest utility is directly corresponding to the satisfaction level. So the service with the highest satisfaction level is selected. So for experimentation, we have used QWS data set. There are 2 experiments. The first one, and in this data set, we have 2,507 web services, which has 11 quality parameters. The first experiment, we are assuming a composition is having 3 services, and they are distributed among 3 clouds. And the number of services, individual services, we vary from 50 to 350. And here we can see the user satisfaction level is higher when number of services is when more number of services is available for selection. So the x-axis is number of services in each cloud. The more the number of services for available for selection, then user satisfaction is more. That is what is observed. The second one is we make the number of services for each functionality fixed, like 50 services are available for selection. But we are changing the number of clouds in which they are distributed. So the cloud platforms are 2 to 10. Here we can observe for till 4 platforms, the utility function is improving. After that, it is decreasing. Means we have to find out the optimal number of cloud platforms where the services are available. That is, after 4 clouds, the satisfaction level is it starts declining. That's what we have experimented with these 2,500 plus services.
We have a limited time.
Yeah, I'm concluding now. So the related work, the existing work, there are a lot of papers on quality-aware composition, but none of the works consider the quality of service of cloud platforms, which we have attempted in this work. And we have also verified with the existing data set QWS, and when the large number of services are available for each functionality, the user satisfaction level increases. Also, up to certain number, here we have found out 4. With 4 clouds, the satisfaction level is more. With 1 cloud, satisfaction level is very minimal. And after 4, the number of clouds increases. Again, the satisfaction level is declining. This is our observation. Thank you.
Yes. Good presentation, Kanchana madam.
Thank you, ma'am.
Only one question is there. Which
Yes.
quality parameters you have chosen for this?
Yeah. For web services, 3 quality parameters like security, response time, and one more. Response time and cost, sorry. And for the cloud platform, 2 parameters, CPU utilization and network utilization. Totally 5 parameters.
Okay. I think you said some 13 parameters it will be there. We spoke in the presentation.
Yes, in the QWS data set, there are 11 parameters. The experimentation is done with that. But the the proof of concept, we have chosen these 5 parameters. But for comparing with the existing data set, we have taken that those 11 parameters and we have done 2 experimentations.
Okay. Thank you.
Thank you. Thank you.
Moving on our next presentation.
Thank you. Can I leave?
Yes.
Thank you.
Yes.
Thank you.
Yes.
Thank you.
Our next presenter is Aman Anand. His paper title is Drone Delivery System Using GPS and Telemetry. Aman, are you there?
Yes, can you hear me?
Yes, you can start your presentation.
Yeah. Are you able to see the screen?
Yes, yes.
Yes, yes.
Don't take too much time. So,
Yeah.
Again, request to all participants, please follow the timing.
Yeah. So, good evening to one and all present here. This is Aman Anand with my team and co-authors Swapnil Das, Ashakti Agarwal, and Andrew Moitina. Today, I'm going to present drone using GPS and telemetry. So, I will quickly go through the outline what I'm going to present today. So, we are going to present the overview, introduction, and objective, the proposed methodology we used to build this drone, the components that we use, and the algorithm through which the entire system is working from order acceptance to delivery. Then we are going through prototype features and finally reference. So the overview is as we know that we are currently going through the pandemic situation and we already faced a lot of problems. And with this, the rise in technology and its integration in our daily life, people's people's preference is quickly shifting to the online mode. And especially for the online shopping, need of delivery person is dramatically
Excuse me,
increased
Aman,
in.
can you?
Yep.
Your voice is too much low. Aman.
Is it okay now?
Still, it is very low.
Just a second. Is it fine now? Hello. Hello.
Hello.
Hello.
Yes.
Yes, Aman, you can continue.
Yes, yes.
Are you able to hear me?
Yes, you can continue.
Yes.
Yeah. So yes, so this type of delivery demand that we have seen in last 1.5 year for online products, it is not doing really well. So there is an attempt that we can use drone delivery system to overcome this type of problem. And drone delivery system that we are currently using is not that economic. So our attempt is to make this type of technology more efficient and more productive. So as we all know, partial copter and drone, which is generally used for drone delivery system to transfer packages from one place to another. This type of vehicle is a part of robotics and automation and can be controlled remotely and can fly by itself. In past few years, the autonomous drone systems has shown significant growth as you people heard about the Amazon Prime service, Amazon Prime Air service, and the motive of that service is to deliver the package within 30 minutes of order. And the technology they are using, the current technology that they are using for communication with the drone from ground station is GSM module, which is not economic as well as not very efficient while communication, because it does not have that frequency on which we can transfer larger data or with the greater speed. So the components that we use in our drone is the first thing is we used Arduino Pilot flight controller, which is built on top of Arduino Mega board. And the three components of that is accelerometer, GPS, and telemetry. So accelerometer is responsible for stabilizing the drone while it is in air. It is basically calculating every angle of drone while it is flying, and helping it to be aerodynamically stable in the air. And GPS is used for global positioning. I mean, to track the location in all X, Y, and Z direction. And the last thing we are using is telemetry. Telemetry is the improvement that we are trying to do in this type of technology, which is to improve the communication between the drone and the ground station. And the motive of writing this paper is to, if someone follow the proposed method of this, then he or she can build this drone from scratch. So first we are using ESC module. ESC is electronic controller, which is used to control the speed of each and every individually. And the firmware we are using is called Mission Planner software, which is responsible for controlling the drone and the calibration process. And after that, we are installing the air module, which is telemetry, to communicate with the drone while it is flying. The working mechanism of entire system is, first we are receiving the order from the customer, and customer can do X. Basically, after receiving the order, the algorithm is going to send the order to the nearest server, and then it is going to find the nearest, and it will upload the necessary information to the drone. Drone will go to the pickup point, and the person will add the package to the drone, and then drone will go to the delivery station and delivery position. And after reaching the delivery position, it will wait for the customers. Wait for the customer's action, that if he has picked up the item, then he is going to confirm. And if he or she has confirmed the order, it means the order has been received, and drone will come back to the landing position, which is done by RTL mode. We will discuss about it now. So our prototype feature is we are using 2200 mAh battery and 1000 kilovolt, which is capable enough to lift 400 to 500 grams of weight, and it can be in the air till 10 minutes. So it can be improved because the prototype that we made is based on our own budget. So that's why we used only 2200 mAh battery. But the same architecture can be used for octocopter and hexacopter as well, which is capable for lifting more heavy weights. Then we are using APM 2.8 controller, GPS and telemetry that you already know, which gives us the uh, features like altitude hold, stabilize, loiter, and RTL mode. So altitude hold is basically it can hold the position in the air. So once the drone is receiving the order, it is automatically uh, going to 20 meters height so that it will not hit any of the buildings in locality. And then it will go to the stabilize mode where it can fly and uh, go to the delivery location. And RTL mode is basically helping the drone to come back to the landing position. So if drone there is a possibility that drone might go out of the communication while flying. So if drone goes out of communication, it is already programmed that in such a way that it is going to come back to its landing position if it is not in communication with the ground station. So these were our all, and it has a lot of applications in uh, like cinematography, traffic monitoring and all. And these are the references that we use.
Yes, Anand?
Yeah.
Yes. Am I audible?
Yeah, you are audible.
Yes. Okay. So for the designing of the drone system, so are you thinking for what type of application this system you have designed?
It can there is a slight improvement that we can do. So while I was explaining the working mechanism of entire system, actually drone doesn't have to wait for the delivery confirmation. What it can do, if we some kind of camera, then it can just take the picture that the package has been the package has been delivered outside the home, and then it can fly. So it does not have to wait there because uh, I mean, because there will be a lot of delivery demands on the same time, so we have to fulfill that as well. So if we include the camera in that, and since we already have the GPS, we can also monitor for. Uh, we can also use this type of drone for navigation system. We can also use for cinematography, like as we used to see in movies. They have they have to have a lot of technology for that. I mean, a lot of uh, other um, other systems they use for cinematography, but drone can help them. And this type of system, which is precisely controlled by the smartphone or PC, can handle all these tasks easily.
Okay. Thank you, Anand.
So moving on next presentation.
You can leave, Aman.
Okay.
Soham Kulte, and his paper title is Detecting Depression in Tweets Using Natural Languages Processing and Deep Learning. Soham, are you there?
Yes.
Yes, you can start and please stick to your time.
Yeah. Is my screen visible?
Yes.
Yes.
Hello, good evening to everyone present in the meeting. I am Soham Gulte. And topic of my paper is detecting depression using natural language processing and deep learning. So these are the topics which we would be going in the presentation. So I will start with introduction. So as we all know that COVID-19 has caused physical, emotional, and psychological distress for people. Due to COVID-19 norms, people were restricted to their homes and could not interact with other people, due to which they turned to social media to express their state of mind and feelings. Uh, so depression is a major contributor to global mental illness, and which influences the life of millions of people of all ages. Before and after pandemic, there is 70% rise in the people affected by depression and obsessive compulsive disorder. So as social media is becoming a major part of everyday life, analyzing languages on social media is becoming a potentially fruitful approach to discover different type of pattern, of which we are talking about here is depressive patterns in our paper. So in India, depression is not classified as a disease due to social stigma surrounding it. Many people consider it as a taboo in India, so which prevents many affected individuals from seeking suitable professional assistance. So with intention to detect depressive behavior through studying languages on social media, we can feasibly capture behavior attributes and analyze the language used by applying deep learning and natural language processing techniques. So early depression intervention programs, particularly for young individuals who are in their teens, can be organized and can be transformed. So we had studied different papers for this, but some of them are mentioned here in our literature survey. So Al-Sagri used machine learning techniques like SVM, CNN, etc. to detect probable depressed Twitter users based on his or her web activity and their tweets, out of which SVM, support vector machine, gave the best performance with an accuracy of 82.5% and a F-score of 0.79%. Islam focused upon different type of factors such as emotional process, temporal process, linguistic styles, and all the three features for detection of depressive text in his paper. Decision tree gave the best performance amongst them all with an F score of 0.73. And the paper written by Singh constructed neural-based architecture such as RNNs, GRUs, CNNs to predict depression, and the word-based GRU model with an accuracy of 98% was highest performing, followed by CNN with an accuracy of 97%. So out of all the papers we had gone through, we found out following research gaps. So majority of the research paper used machine learning algorithms such as naive Bayes support vector machine SVM to classify the tweets. The ones which had deep learning architectures used complex neural networks, and their performance were now not up to the mark. And most of the research paper used bag of the words for feature extraction, and in none of the papers sentence embeddings were used, as we know that sentence embedding can be quite fruitful in such models. So we have tried and implemented sentence embedding in our model. So data set. So we manually scraped a data set to get required number of tweets by using Twitter's lookup operators and APIs. So for scraping the data set, we use certain phrases which like show some depressive thoughts such as alienated, I am crying, kill myself, worthless, end it all, etc. So this would depict certain tweets which are showing depressive thoughts, and we could not annotate automatically because it was producing a lot of false positives. For example, what is Chelsea doing makes me want to kill myself. here makes me want to kill myself is the words highlighted in the phrases, but this is a false positive. That is, we cannot tell that user is truly depressive when he is tweeting this, because he is right now sad or angry because his favorite team, that is Chelsea, is not performing well. So we had to do manual annotation only. There were total 17,620 tweets in our data set, out of which 6,774 indicated depressive behavior and 10,846 were indicating non-depressive behavior. So this is an overview of the system architecture, which I would be explaining in the further slides. In pre-processing, we found out that some people tweeted in local languages using English alphabets. So such tweets were removed. Like many people in India use English alphabets to write different words in Hindi, as some of them we call it Hinglish. So we also removed the mention of usernames and any hyperlinks to maintain anonymity of the user. All the characters are converted to lowercase and only alphanumeric characters are kept. Here we removed all emojis and all. So in order to avoid class imbalance, we also scraped many of the random tweets on different topics to maintain an equal data set. We get sentence vectors using spacey models, which are then passed into our neural networks. For LSTM, the input is sentence vector, which does not contain any semantic information, as the data is still sequential. So we represented text as a matrix instead of using pixels, where each row of the matrix would represent a sentence and are eventually passed into CNN. So these are the loss and accuracy plots and performance analysis of MLP, that is multi-layer perceptron. Here, optimizer and hyperparameter were chosen by hyperparameter tuning, and they weren't chosen at random. So accuracy obtained for MLP was 0.94 here. Adamax is superior to Adam in models with embeddings, and accuracy obtained for CNN was 0.93. And accuracy obtained for LSTM was 0.93. So this is the comparative analysis of algorithm which we have performed. We use 3 algorithms, that is MLP, CNN, and LSTM, out of which MLP had an accuracy of 0.94%, precision of 0.9, recall of 0.9, and F1 score of 0.9, and followed closely by CNN and LSTM. So here, I would like to conclude that the models mentioned in this paper can be used by mental health professionals for detection of depression on various social media, apart from Twitter also, and for timely detection before the conditions get worse. 3 architectures were used in the research, that is MLP, CNN, and LSTM, which were given sentence embedding as an input. Hyperparameter tuning was done. So to obtain best performing combinations for each of the neural network, and the best performing model, which was found out to be MLP with an accuracy of 94%. And in future, we can classify the user tweets according to different level of severity. That is how severe are the level of depressions depending upon the tweets. And this experiment could further mark the infrastructure for new procedures which can be applied in different areas of healthcare and medical facilities to detect depression at an early age for timely diagnosis. Thank you. I'm open for questions, and these are the references which I've used in this presentation.
Okay. Just you are detecting this phrases, depressing words like that.
Yes, ma'am. These words.
Are you guiding somewhere if you found that tweets and like that? So are you just you are detecting, no?
Yes, ma'am. Right
tweaks?
now, we are only detecting, and we are like doing more research in it to like many different like Twitter and all. If we post such things, they are now navigating users to different websites to seek some medical attention. But not all the words which are mentioned here would declare or indicate depressive behavior. As the example was given below, what is Chelsea doing makes me want to kill myself. So that is the
Uh,
challenge here.
Okay, another one question. Have you classified the category, means age-wise categories? So if it is a student, exam-related questions or exam-related burdens will be there, or in the middle age, like that. Do you have any categorization for the human beings?
Uh, right
Sorry, have you
now,
categorized that? Huh.
yes, no, we have not categorized it as of yet. But while we were scraping the tweets and all, I think it was during peak of second level of second wave of COVID. So many students were putting out tweets to cancel exams and everything, as many centers were conducting offline. But as you mentioned that for a certain time period or anything, we can add more phrases related to certain exams
Yes.
and all.
Yes, yes, that will be my suggestion. That so depending upon that, their phrases and again it will be different.
Yes, ma'am, depending upon situation.
Yes, yes, yes. Okay, thank you,
Okay, thank you,
thank you,
ma'am.
Soham. Okay. Next.
Our next presentation for Anu Bharti in her paper title is Transfer Learning Approach for Diagnosing Skin Cancer with Deep Convolutional Neural Network.
Shall I share the
Okay.
screen, sir?
Yes, you can
Yes,
share.
yes,
Yeah.
yes,
Yes.
yes.
Yeah. Good evening to one and all present here. Myself, Dr. Anu Bharati, Assistant Professor in the Department of CSE at Satyabama Institute of Science and Technology, Chennai. And my co-authors are Dr. S. Poongolili ma'am and Dr. S. Vinod Kumar sir from Rajalakshmi Engineering College, Chennai. So our paper title is Transfer Learning Approach for Diagnosing Skin Cancer with Deep Convolutional Neural Network. So the objective of this paper is to develop a pre-trained deep learning network and transfer learning for automated skin cancer classification system by using ResNet 50 V2 model. So there is a difference between the traditional machine learning and transfer learning. So transfer learning is a technique that enables the algorithms to learn a new task by using a pre-trained models. But in case of traditional learning, a machine learning algorithm works in isolation. When we give a large enough data set, it learns how to perform a specific task. However, when the task to a new problem, it cannot resort to any previously gained knowledge. So instead, a conventional algorithm needs a second data set to begin a new learning process. So in transfer learning, the learning of new tasks relies on previously learned tasks. So the algorithm can store and access knowledge, and this model is more generic than specific. And the main advantages of using the transfer learning, which increases the learning speed. So that is a major advantage of transfer learning. So we have taken transfer learning for our model. So these are the different models of transfer learning. So these are the more popular models of transfer learning. The first one is VGG. So there are different flavors are available in VGG model. So VGG 16 or VGG 19. And also we have Google Net, and it's an example for Inception V3 model. And also residual network example for residual network is ResNet 50. So we have used ResNet 50 V2 flavor. And so this is the architectural design of our proposed system. So we have used Kaggle dataset, skin cancer dataset. So skin cancer is the world deadliest form of cancer. So the tumors on the skin or abnormal growths of tissues that can be either malignant or benign. So we are taking the skin cancer dataset. So it's a Kaggle skin cancer dataset. Totally, we have taken 2,637 images, and we are feeding that dataset to the ResNet 50 V2 model. So this is the ResNet 50 V2 model. So in the ResNet 50 V2 model, it consists of the input block, the classification block, and the output block. So in the input block, so the feature extraction can be done, future mapping will be done, subsampling will be done, and conclusion is happened. And in the classification block, the conclusion and the batch normalization and ReLU activation function, and it consists of max pooling and also the convolution blocks. And in ResNet 50 to V2 model, we have identity blocks. So after several iterations of convolution block, the identified block is processed, and in the output block, it consists of the average pooling, and we can flatten the output layer, and also we have consist of ReLU activation function with softmax activation function. And by using ResNet 50 model, the classification is done, and it can be classified. This particular image is classified into malignant and benign. So we have used ResNet 50 V2 architecture for design our model. So ResNet 50 V2 is a modified version of ResNet 50, and it consists of totally 50 layers. In the 50 layers, we have 48 convolutional layer, 1 max pool layer, and 1 average pool layer. And totally, it has 3.8 into 10 to the power of 9 floating point operations. So this is your deep residual framework. So it introduces shortcut connections that simply performs identity mappings. And here X is the input. Here X is the input of first few layers. So the neural net could approximate any complicated functions based on the idea that h of x is equal to f of x plus x. So this f of x plus x create the residual net. And when the traditional neural networks will learn only h of x into h of x, but in case of ResNet model, the layers to learn the residual of input and output of the subnetworks. And here the ResNet could just forward the gradient from the last layer directly to the first layer, So this is the actual functionality of deep residual learning network. Actually, this ResNet, we have used ResNet because it solves vanishing gradient problem. So when we add more layers to our deep neural networks, the performance will become stagnant or degrade. Okay, so for that purpose only we have choose ResNet 50 V2. So this ResNet 50 V2 solves mainly the vanishing gradient problem by using this identity shortcut connections. So results and discussion. So we have used ImageNet weights for constructing the ResNet model for image classification. And we have used 4 dense layers for that is added to the ResNet model. So the training data set, totally we have taken 2,637 images, where the image size is 224 into 224. And we have chosen RGB image with 2 classes, namely benign and malignant. So we have tried with more images by using augmentation technique. So here we have applied 2 augmentation process. The one is the geometric augmentation, in which we have applied anti-clockwise rotation, and we have also done clockwise rotation, horizontal flip, and vertical flip. And also we have done color augmentation by using blurring and adding some noise to the image. And after augmentation, the total number of JPEG images is about 3,297. The testing data, so we have tested the data set in the testing data set, which includes 660 images with 2 classes, namely benign and malignant. So this is the result of our proposed model. So we have taken Kaggle skin cancer data set, and these are the accuracy. So for the original images, we got the accuracy of 98.25%. And for augmented images, we got 99.58 images. So the accuracy is nothing but it's a number of correct prediction divided by the total number of predictions. And also we have compared our model with the existing models such as symmetric type, joint reverse, ANN, SVM, and also the AlexNet model. And for symmetric type, we got the accuracy of 83%, joint reverse 92, ANN 92.5, and SVM 96%, and AlexNet is 98.61. So we have compared our model with this predefined models. So in our model, we got 99.58% with augment images. So this is a graph which explains the classification rates of the proposed and existing process. So we have compared our model, proposed model, with the other types, symmetric type, joint reverse, ANN, and SVM, and also the AlexNet model. So in our model got the accuracy of highest accuracy of 99.58%. And also we have tried ResNet 50 V2 model. We have compared ResNet 50 model with another transfer learning approach called as VGG16 model with 8 epochs. And within 8 epochs, the average accuracy we got for ResNet 50 V2 is 97.
Dear presenter, please conclude presentation.
Yes, sir. Yes, sir. Okay, 97.41%. And for VGG16, we got 85.06%. So, we have compared the transfer learning two transfer learning approach, and we conclude that ResNet 50 V2 is best comparing with the other models. Summary. So the transfer learning involves using the models trained on one problem as a starting point, and it can be used for other problems. And the results are compared with the existing models, and the proposed system reaches the highest classification rate. And also the finding shows that ResNet 50 V2 is a better compared with the VGG16 model. So these are some of the references we have used in our paper. Thank you. Thank you, ma'am. Yes. Questions? Yes.
Thank you. Only one question. Have
Yes,
you validated these results with the medical?
Yes, ma'am. Actually, yes. This is a data set we have taken from Kaggle, but we are not compared with any medical data. Okay, this itself a medical image. We have taken from the Kaggle data set, and we have do the classification by using this Kaggle data set, and this Kaggle data itself collected the images from the medical.
No.
Okay.
So what results you are getting? Have
yes,
is there any doctor's results and like that I want? I know that.
No. Yes. Said. Yes. Yes, ma'am. Actually, we have. Yes, ma'am.
Okay. Thank you.
Thank you, ma'am. Thank you.
Moving on, next presentation is Madhuri Parekh, and her paper title is Survey of Streaming Clustering Algorithms and Machine Learning on Big Data
Sorry
Architecture.
to interrupt you. So can I speak
yes,
if you do provide me permission? Dr. Prashant Vats, code number 212. I have joined a little late, so sorry for that. Code 212.
Your presentation is after this presentation, sir.
Sure, sir, sure.
Yes.
So, Madhuri, are you there?
Madhuri.
Yes.
Yes, you can start the presentation.
Start. Yes.
Okay. Thank you. Just a minute. Now is this all viewable?
Yes, visible.
Okay. Good evening to all of you. Myself Madhuri Parekh and my co-author is Dr. Madhu Shukla. And today's topic is survey on streaming clustering algorithm with integrated machine learning to big data architecture. So that is the index abstract. Today I present abstract overview of big data analytics, overview of clustering algorithm, literature review, existing model problem survey, proposed system, methodology, conclusion, reference, question and answers. So in my today's presentation, my abstract is related to machine learning and big data. There are the number of problems are arise whenever the number of data are going on with our internet. So there are the large data streaming are there. So in that data streaming, how the machine learning is integrated with big data and how it can resolve the number of problems over there. So that is using of one clustering. So that is the one particular research objective, and the abstract at here, I can use the clustering algorithm, and in that clustering algorithm, I can use the machine learning with a integrated with a big data. So I observe one particular algorithm that is known as a auto cloud. That is existing algorithms are there. In auto cloud, they can use the data architecture, and my proposed algorithm, it should be a ML auto cloud algorithm, which can use the machine learning with PySpark architecture, and it can solve the number of problems of auto cloud algorithm. That is one abstraction. So here it is a overview of big data analytics. So there are the number of numerous data are available into the internet. When the data are coming either in a structure wise, semi-structure wise or unstructured wise, at that time we have to use some machine learning algorithm, and using of that machine learning algorithm, we have to expose our data, and we have to give our data in a very speedy manner, very precise manner. So that is a one contribution of big data with a machine learning. So at that time, the machine learning is very useful with a big data. So in the big data, there are the 4 characteristics are there: volume, variety, velocity, veracity. In that, my main objective is at here analysis of data, that is on real-time clustering. Clustering and data streaming are related to real-time problems are there. So that is a velocity. So according to this 4 characteristic, I have to survey on this particular analysis of data. The importance of big data streaming, we have to know internet, there are number of real-time data are generated. That real-time data sets are very low latency are there. So that is we have to improve that low latency into the fast rate. So that is a necessity of big data streaming analysis are there. So at here I say that machine learning on big data, how it is useful machine learning on big data. So that is a one framework. Whenever the number of data are coming from the big data, so that is first going with pre-processing. After that, there is one model. It can evaluate with unsupervised learning. After that, it evaluate if there is some kind of changes. Again, it go with a pre-processing model. At that time, number of users and domains are available, and it is connected with the system. So it is a framework of machine learning on big data. Okay, so that is one kind of framework is used at here. In this particular part, when we say that is a pre-processing, so pre-processing have the number of issues are there: redundancy, inconsistency, noise, heterogeneous, transformation, labeling. There are number of lots of problems are arise whenever there is a pre-processing. After that, there is a data preparation is also one kind of costly requirement of that. So the meaning of that thing is that the big data have the number of characteristics are there. In that characteristic, if we integrated with machine learning, at that time it can solve the number of problems of the streaming data sources directly. So that's why I can integrate the machine learning on big data. So that is a machine learning characteristic: supervised learning, unsupervised learning, and reinforced learning. In that, my survey is on this particular part, that is a clustering, that is a unsupervised learning. So according to them, I can make one chart at here. There are the number of challenges are there: volume, variety, velocity, and veracity, and that are the approaches of the machine learning. There are the number of machine learning approaches. I guess there is algorithm, processing, data manipulations, and learning paradigm. There is a deep learning, online learning. There are number of approaches are available. My main concentration at this place, that is online learning, and there is a part of the velocity. This is the one particular part for my survey. Okay, so that is the number of approaches and the number of challenges are there. That challenges is done, already researched over there, and some challenges are partially done, that are not fully done, and the blank is rather than they cannot yet research over there. Okay, so that are the one particular chart. So according to them, I can say that I can use the clustering algorithm, because we have to know in a data mining, when we have to extract some knowledge over there, the clustering is very useful over there. Whenever there are number of, suppose I can say that there is a weather forecasting data with us, and after that weather forecasting data, suppose I want to divide that weather forecasting data into some groupism. At that time I can use the clustering algorithm, and that clustering algorithm, that means clustering stream data algorithm, and that have the number of advantages and disadvantages of number of streaming data are there, number of streaming clustering algorithms are there. In that, first is a stream, clue stream, HP stream, then stream, D stream. That are the number of approaches is used, either partition and hierarchical. According to them, it have some advantages and disadvantages are there. So first one is the space and time complexity is low. That is the advantage. But rather than the disadvantages, it does not have a flexibility of computing the cluster at the user defined time period. Same way in a clue stream, it does not support concept of drift to give the cluster of arbitrary shape. This is one particular approach we have to use in our proposed system. We have to reduce some concept of drift over there. Then there is a number of average number of projected dimension parameter and number of cluster require detailed domain knowledge in HP stream. That is one disadvantage of that. Then after dense stream algorithm, it is approach is density based. It have advantages. It give a arbitrary shape cluster. But whenever we have to merge or when we have to separate the cluster, at that time it does not allow any kind of memory space over there. Then D stream, that have one disadvantage, does not support handling of multiple dimension data. So that are the number of another clustering algorithms are there. That is E stream, DB scan, stream optics, MR stream, HDD stream. That are number of algorithms are there which have an advantage and disadvantages are there. So that is one particular aim of my survey paper. I can find out the number of clustering algorithm which have advantages and disadvantages are there. About there is a 25 algorithms I can compare at here according to the advantages and disadvantages. So from that I can find out some literature review over there. There is one paper that is evolving approach to data stream clustering based on typical and centricity
Dear
data
presenter,
analytics.
please conclude your presentation. We have limited time.
Okay. So that is a literature review, and from that literature review, we have some existing problems are there. The single scan clustering, limited time, limited memory, unknown number, evolving data. Then after there is a noisy data. So that are the number of problems I can find out into my survey. So that is the one particular algorithm that is known as the auto cloud algorithm. This auto cloud algorithm is used the data architecture, and according to them, they can use one particular Euclidean distance on sample data and they can find out some result. So my proposed system is there. I can make one overview at here. Instead of Euclidean distance, I can use Melhorn-based distance over here, and I can find out some accuracy over there. So that is my overview of proposed system. So that are the one particular conclusion from my side. When we have to data stream clustering, there is a number of challenges are there. And that number of challenges, I can find out one main challenge, that is concept of drift, and another is detect of arbitrary shape, that I will solve in my proposed system. And my proposed system, it should be said, that is ML auto cloud algorithm, ML auto cloud algorithm on PySpark architecture. So I can revise the auto cloud algorithm with use of machine learning and PySpark architecture, so that can fulfill uh, my research part at here. So that is from my side. That are the references. And thank you. Any question answers from your side?
Thank you, madam.
Yeah. Thank you.
So moving on to next presentation, Prashant Watts, and his paper title is Comprehensive Framework for IoT-based Data Protection in Blockchain System.
Good evening, ma'am. Am I audible to you?
Yes.
And I request
Yes.
all that please take your time.
Yes,
So
yes.
more 4 presenters after that.
Okay, sure. So my screen is visible to you, ma'am. Basically, my
Yes, yes.
presentation is on comprehensive framework that we have proposed based on IoT data protection using your blockchain system. So abstract is there. We know that very well that thousands of IoT equipments have been connected to share information and services over the cloud. And over there, IoT security and protection is a major issue because of the growing number of IoT devices where have been data has been obtained, including persistence, assessment capabilities, scalability. Blockchain technology has been tackling with security and security safety concerns that we have studied. So our article basically demonstrate two unique commitments. One is an ultra-light customizable blockchain technology and a scalable time-based consensus map. Here we have established an overarching network and the great assets devices which have been collaborated to deal with the blockchain technology and preparing expenses and pro customization using your time-based general agreement. So as you know that blockchain technology and internet of things, they are interrelated, you can say somehow interrelated for the informational data blocks, that is basically including the hashes of preceding block, comparable to an under, or you can say ordering list, where basically you can say for the widespread consensus over the internet of things, we have been seeing now, it has been commonly assumed to be highly secure. So blockchain is basically what we have seen is a distributed ledger that have received a lot of attention from the professionals and researchers across different fields due to its numerous advantages, including decentralization, anonymity, confidentiality, and persistence. So this was the technology that we have seen, that how it basically works based on the hashes of previous, you can say block headers, and based on your transaction series transactions. So this was our proposed work where we have basically expand the blockchain's flexibility with grouping over, you can say, arching nodes that integrates IoT system. Basically, we have analyzed the square that can be attached to a blockchain to create the distributed record. And this partitioning is actually enabling, you can say, your unicast directing direction of your, or you can say unicast directing of your information packages, that has been resulting in reduced delay and bundling cost for your transferring information. So this has suggested that it can solve the, you can say, shortcomings in present configuration as suggested in your release promotes ma'am. So to operate the operating cost, sorry, to reduce your operating cost, we have basically divided the overlying architecture into distinct groups and group heads. So our, you can say, findings, they have discussed with a time-based conventional wisdom computation that reduces your mining preparatory cost and delay ma'am. So this was the, you can say, proposed architecture that we have given, where the cloud storage and the central controller has been, you can say, been working. Then the time-based convergence method we have given, that basically preventing technology for, you can say, technically with the block administrator for repeatedly claiming to have, you can say, limited prolonged waiting period. And it has been differing for overlay framework administration and administering as well. And you can say in the preceding organization, it has been compensated twice with your severe beginning delayed. This is the algorithm that we have used for your overlying transaction, where have been hash has been given to you, and then you are releasing your signatures. And these were our, you can say, tables that we have been validated with our results. And these are the specifications that we have taken for the you can say blockchain security. Like previously we have taken up completeness, availability, non-repetition, and the authentication with the employed method. So jumping on to our conclusion, basically we have argued that while blockchain technology is strong invention for your privacy and reliability in IoT, it's been used in the IoT paradigm, offering a number of significant challenges. It has been including your complexity, transmitting data capacity, idleness, overhead cost, and scalability, where we have proposed a scalable, lightweight blockchain for to overcome these challenges. And it also includes your amicable consensus computation that not only eliminates the need to settle any enigma which has been prior to invading and occupying your new sector to the databases, but it is also combining a distributed trust mechanism in which the discrepancies block manages per data packet handling, time, duration, and latency. It has been decreasing that acquire confidences for one another. So it exceptionally safe against a wide range of attacks according to your security testing as well that we have found, ma'am. So these are the references that we have taken up. So any questions onto this if you would like to ask, then this is the presentation now. So can I conclude, sir?
Yes.
Okay. Thank you, ma'am. Thank you so much. Thanks for your time. Thank you.
Moving on, next presentation. Gide Indrawan.
Yes.
His paper title is The Analysis of Noto Serif Balancing Font of Support Computer Assisted Transliteration to Balancier Script. Mr. Indrawan.
Yes. Am I audible?
Yes, you can start.
Yes.
Okay. Let me share my screen. Okay. Thank you very much for the time. Let me introduce myself. I'm Gede Indrawan from Universitas Pendidikan Ganesha, Bali, Indonesia. And yes, at this time, I will present about our research with my team related to the analysis of Noto Serif Balinese font to support the computer-assisted transliteration to Balinese script. Okay, the outline of the presentation consists of introduction, method, result, and analysis, conclusion, and feature work. On the introduction, here the study is aimed to preserve the endangered Balinese local language knowledge through technology by analyzing Noto Serif Balinese font to support computer-assisted Balinese script transliteration. This research has never been done before and contribute to the future improvement of that font development for wide use on the computer system, including the smartphone. Is eventually strengthen the ubiquitous learning of Balinese language, which is a mandatory local subject from basic to high school in Bali province, Indonesia. Go to the method. Here, this analysis was conducted on Noto Balinese web application. We have the application that was developed as a technological product of Universitas Pendidikan Ganesha Indonesia. And the app is basically receive Latin text input and output Balinese script. It's considered as the first Latin to Balinese script transliteration web application based on Notocery Balinese that support dedicated Balinese Unicode. So we have the font that using the Unicode that universally known on the computer system. Go to result and analysis. Here, through the experiment, NSB font capability should be enhanced on the font construction design by providing, we have three aspects here. First, providing wider glyph for certain appended form or known as gantungan in Balinese terminology. Second, by providing higher glyph for tedung, for form known as tedung in Balinese terminology. Third, by providing repositioning glyph for certain cluster of vowel sign, consonant sign to avoid overlap rendering. The example of those of three improvement can be seen on the next slide. For the first aspect related to wider glyph for certain appended form, we can see for the next slide here that for case, yes, for the case one, as we can see, glyph of appended form, we can see with the blue highlight section at the left side, that actually is the application result is narrower than its counterpart glyph of the reference as the ground truth of the transliteration. And the reference result, we can see the comparison at the blue highlight section at the right side. For the example for the second aspect related to higher glyph for form known as tedung in Balinese terminology, we have the example for case 5. We can see the blue highlight section at the left side, which is the result is generated by the application, the transliteration application. Glyph of vowel sign tedung is shorter than its counterpart glyph of the reference. As we can see, compared to the blue highlight section at the right side.
Excuse me,
Yes?
are you showing some architecture diagram, something? Because
no, yes.
Because you are on the slide where you are mentioning the method.
Yes, yes.
I think the slides are not moving.
The slide is not moving. Can you? Okay. Sorry,
what you are explaining, I think it is a architecture or some diagram you are explaining, no?
Actually, the diagram also is not on the paper, but because it is improved from the previous paper. So here we just highlights, we just expose
Just
some.
we are explaining. Okay.
Yes.
Go ahead.
Yes. Okay. Thank you, ma'am. Okay. Yes. For as I continue for the third aspect related for the profile for the enhancement for the existing NSB font capability is about the positioning glyph. And the example or the illustration we can see for the case 7, there are overlapping on glyph rendering between vowel sign, and we can see at the blue highlight section at the left side. That is generated from the application and compare to the ground truth, the reference result at the blue highlight section at the right side. Okay, go to conclusion and future work here on this research. Yes, this is the improvement. This is the continuity from the previous work, and we have the architecture, but yes, because of the limits of time, I cannot show now. But we have some feedback from the NSB fonts that actually developed by Google and from the existing now, there are still no drawback as we expose in this paper. So yeah, for the conclusion that noticeable relevant capabilities should be enhanced on font construction design for certain aspects as we described previously. And in the future, yes, okay, related to the study of this font capability at certain perspective and strengthen the translation knowledge. And why we say what the ubiquitous learning, because this form also can apply on the mobile system, because the font using the Unicode code, so it's a universally detected by the mobile system. In the future, accompanying algorithm of the studies should be improved by taking care of line breaking mechanism and enriching in special word repository. I think that's all. And the last, as the acknowledgement, this work is part of the research grant funded by the Indonesian Ministry of Education, Culture, Research, and Technology. Thank you very much.
Thank you. But here in this presentation, so that is a clear picture or system architecture. These slides were missing. What do you want in the presentation that is missing?
Oh, okay. Am I still have time maybe to show?
No.
Okay.
No. Outline of the presentation, your system architecture, what algorithm, basic things are missing in the presentation. Just you are explaining, just you are reading like that. So that will be, means you are not getting anything. What you know that architecture, that's why you're explaining. But
yes,
that audience should understood that, na? So your system architecture, your algorithm, your modules, so it is not there in the presentation. So that my suggestion is that you will have this type these things again, it should be added in the presentation.
Thank you very much, ma'am, for the feedback.
Yes. Okay.
Next presentation is M. Himwant Sai. His paper title is Cost Validated Canonical Variate Analysis for Damage Grinding After Math of Earthquake Building. Himawant, are you there? Himawant Sai. Hello.
Yes, sir. Can you
He
hear?
is there. Jay. Yes.
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 You can start presentation.
Yes, sir. Just give me a moment. Okay, good evening, one and all. Today we are going to. Am I clear, ma'am?
Yes, complete in
Yes.
short time.
Yeah. So today we are going to present topic cross-validate canonical variety analysis of damage grading aftermath of earthquake building. So what is it? What is it we are going to do actually? Since we all know seismic events happen and destroy the structures, which is very dangerous to the human life. So due to the innumerable sources of environmental uncertainty, estimating the earthquake damage to buildings remain very difficult task because it does not just include a single factor. It includes multiple factors such as amplitude, proximity of geographic center, and compliance and building reliability, etc. So examining the damage rate of concrete structural system is critical for acknowledging the maintenance and need avoiding the level of damage during the next catastrophic event. What we are basically doing is we are taking the previous experiences and applying it to the structure, so that next time when if anything happens, we can reduce the damage happening. So as we all know, earthquakes are very one of the disastrous natural disaster event occurs, and it threatens human life in very large scale. So the severity of earthquake structure damage is determined by these various factors such as size, distance, focal point, land conditions, and seismic structure of execution. So the ability to quickly assess the distribution pattern and severity of building damage is essential for post-emergency for response and recovery, so that the further suffering can be minimized. So building damage grade categorizations take a substantial period of time, personal resources, and it can take several months to analyze after the earthquake. So by using this, we can assess the seismic risk, and which is critical for preparing for the appropriate steps when, if at all, it occurs next time. So these are few related works. This paper is also a fictional scenario weakness based and top
I think you're not. Yes, excuse me. I think you're not shared your screen.
Ma'am, for me it is showing your screen sharing has been started. Just give me a moment, ma'am.
No. Your presentation is not visible. You're not shared your screen.
Ma'am, is it visible now?
No. It's not visible.
Okay, I'll do it once again. Just give me a moment.
You can stop and start again.
Okay, sir, is it visible now?
Is it visible, madam?
No.
Is it visible, sir?
Is it visible, madam?
No, sir.
Sir, here
Screen is not visible. He is visible, but screen is not visible.
The screen is started, ma'am. You can't see the screen. Share.
No.
No, sir. Actually, for me, it is showing that you are sharing your screen sharing.
Yes, I can see your screen, but madam can't see.
Yes, sir, but
I don't know.
I do have only one option, right, sir, to share the screen, and here it's showing you are sharing the screen.
There will
Sir,
be technical some issue, so.
Jay, you are seeing his screen?
Yes, I can see.
Presentation is visible?
Yes, madam.
Presentation is visible from our side also.
Oh.
So once again, let me stop sharing and reshare it, ma'am.
Yes, you can do that.
Ma'am, is it visible now?
No.
I'm doing my best I can, so, but
okay. Means this problem is from my side?
Yes, ma'am, might be, because if any other can see the screen, then
But
problem might be.
previous presentation, it was visible for me. Previous presentations.
I'm sorry,
I can
ma'am.
see the slide.
All
Ma'am, the
participants
screen
can
is
see.
visible.
Okay. All are seeing the screen?
Presentation is visible to all of you?
Yes,
Yes,
ma'am. Presentation
yes,
is
ma'am.
visible.
I can see the transition.
You can rejoin.
Okay, I will again rejoin. Okay.
Yes, madam.
Okay.
Sorry for the inconvenience.
No problem, sir.
Hello.
Yes, sir.
Yes, now,
Yes,
yes,
madam.
yes, visible.
Okay. You can
Sorry.
continue.
Ma'am, do I have to start over, or shall I continue from where
Yes,
I
yes, please continue.
Yeah, so these are the
Yes, yes.
few related works, as you can see. So this is all basically for, to help the prediction after uh, occurring the earthquake. So these are few related works. And our contributions are, firstly, the earthquake damage data set is processed with the missing value estimation, categorical future and encoding and feature scaling. This is one of the contribution from our side. And data set will have all 26 features applied to all the classifiers to grade the damage with and without component scaling. And performance is analyzed while by cross validating and training the data with 18:20 and 17:30 and 16:40 ratios, according to the grading of the earthquake which is going to occur. So the data set is minimized with 10 to 15 linear discriminant components, and then applied to classifiers to grade the damage with and without the component scaling. And the performance, which is analyzed again by cross validating the training and testing the data with 18:20 and 17:30 and 16:40 aspects by the help of the previous data sets. So the metrics used for analysis are precision, recall, F-force accuracy, and execution time. So this is the overall workflow uh, of our project. So first, we analyze the earthquake damage data set. Then we'll see the missing value and categorical encoding. Then we'll be splitting, training, and testing the data set. And so, as here we have already said, it has all 26 classifications or features included for the testing. And then we'll be doing the feature scaling in the following aspect ratios, that is 18:20, 17:30, and 16:40. Then apply the linear discriminant analyzer algorithm with 10 to 15 components. Again, we'll be classifying and fitting with these same aspect ratios of the training and testing data set. Then afterwards, we do the analyzing of precision, recall, F-force, accuracy, and runtime. And finally, we predict the damage grade which has happened. So this is the target. This is how we are going to classify the amount of seismic level earthquake and the damage which happened. So we are taking it into 5 grades, in which one is gonna be the least and 5 is gonna be the highest. And this is a glimpse of our data set or the parameters which we are going to pass. So again, these all are as I've said, 18:20 feature scaling and all. So here we see what kind of precision, what kind of score we are getting, and what's the accuracy and all. Ma'am, am I clear?
Yes, yes.
So again, in the similar way, we are going to test with another aspect, and that is 17:30 and 16:40. So here, basically, we are going to do an before math and after math of scaling. So once left side parameters are all before scaling, and right side is going to be the after scaling parameters. And this is also the same, but again, it's with 18:20, and similarly by changing the ratios. And may I conclude?
Yes, yes.
So an attempt is made in this paper to analyze the mushroom dataset by exploring correlation between features. And experiment result shows that kernel SVM, KNN, and ADA boost classifier of FA reduced dataset tends to retain most 100% accuracy before and after the scaling of the activity. Then the KNN classifier with LDA reduced LDA, linear discriminant analyzer reduced dataset tends to retain 96% of the accuracy before and after scaling of the earthquake damage or grade of the earthquake occurred. In similar way, from above analysis, KNN classifier is found to be more efficient and accurate with all other reduced data sets such as PC and FA. And these are the few references we have taken from the previous journals and articles. Thank you.
Thank you.
Ma'am, would you like to give any suggestions?
So how this KNN is suitable here in this work? KNN?
Ma'am?
How is KNN algorithm?
Yes, ma'am.
In the conclusion, KNN algorithm.
Yes, ma'am. Just give me a second.
Last slide. You used ADA boost, KNN. Second point.
So basically KNN is the nearest neighbor algorithm for machine learning, right? So it takes the, as I said, we'll be grading it based on previous incidents, right? So in the previous incidents, it's gonna take the parameters of what happened here, such as like we have a proximity scale and seismic activity level scale, right? And forces scale. Based on these parameters, it will be analyzing through with the previous data set which we provided, which has similar set of parameters.
Okay, thank you.
Thank you, ma'am.
Moving on, next presentation. Prashant Vats, once again, identification of MRI based innate tumor with 3D convolutional system. Prashant?
Yes, sir.
Yes,
So
we
can
can
I share
start.
my
And
screen, ma'am?
yes,
Okay, ma'am.
Yes, yes.
Okay.
we have a limited time. So after this, one more presentation.
Okay, okay. So, ma'am, this presentation is an identification of MRI-based adrenocarcinoma tumors with your 3D convolutionary system. So basically, uh, here we have done the work onto, you can say, imaging techniques for uh, you can say pancreatic cancer, basically, that helps the physician to achieve better diagnostic accuracy and if you can say efficientness, which is based on subjective judgment on experiences that has been done on the you can say imaging classification using three variants, that is ResNet 18, 52 and 34, and inception ResNets we have done through our study, and we have suggested a normalized gradient descent to basically impact the imbalance data during the MRI scanning and all that, and categorization of pictures. So where our that categorization with Iris Net 18 has given us the most efficient and attains 91% precision. So we have seen during the study that during the last several years, the fatality causing with the pancreatic cancer, or you can say the tumor genesis, has been increased with the changing lifestyles of people, and you can say categorization of tumors based on the imaging and all that is you can say still a challenge. So to employ the machine learning technique to basically predict specimens, or you can say for the accurate predictions of your cancer images during the specimen. So for combining the medical information with the patient plus precise imaginary knowledge has given us this motive to study into this area with the RF classifiers and the convolution learning algorithm. So this was the related work that we have seen in the past of the few researchers, and this was the proposed model that we have given, where basically images that we have obtained from the various hospitals and departments have been gathered, and you can say 3D convolutionary networks we have applied with these four data sets that we have: RSNet 18, 34, 52, and Inception ResNet. And the image has been classified into the benign tumor and the malignant part. And this was the data preparation that we have demonstrated, where the MRI pictures have been taken onto these scales, where basically magnetic resonance images photograph that we have collected from the local hospitals here in Delhi that we have taken up. And you can say these are the pancreas visualization after the exponential rise that we have obtained and analyzed during our study in the this thing part. For this, we have obtained classifiers with the 173 datasets that we have used for 690 samples, and GTX 180 Ti's chip has been used to speed up all the tests. MRI scans of 20 regular people that we have also taken up to for the contrast to basically picture out that how the configuration has been taking place. So here we have performed two sets of comparative studies to demonstrate the correctness and the logic of your suggested gradient descent, where basically first we have categorized the pancreas image data with four classifiers that I have told you, with cross entropy, non-linear function, inception, ResNet. Five criterias we have analyzed with the outcome of allocation. So the results we have seen with that proposed system, that 82% efficiency can be obtained with the proposed system. So these were the findings that we have gone find out by applying the data sets, where you can say with every trial the data has been improved. And conclusion is that in classifying the pancreatic tumor, basically we have used four networks, where three-dimensional convolutional neural network with the parameters ResNet 34, 34, it's been mistaken. It's been RSNet 18, 52, and original conception has been taken, where RSNet 18 has been proven up the best, you can say, position And also for the image analysis, the breadth and depth of your connection, they can be further enhanced. It has been a future work where you can say the weighting gradient descent, it is to be worked out over there. And these are our references that we have given up. So any question on this one, please? I'm audible, sir?
Yes,
Okay.
you are audible.
So this was the presentation, ma'am. Thank you so much.
Thank you. I think this is a nice topic for this. Validation, again, again the same thing regarding the validation.
Validation part, ma'am, actually the problem is that with the pancreatic cancer, it's not about the pancreatic cancer we have studied. We have done the study on the, you can say the breast tumor as well. So validation is again with the pictures that scans that we have been obtaining and the convolutional neural network that we have applied. Validation can be taken up with the proposed algorithm that have been already done by the researchers. And this data actually we have gathered from 4 main hospitals of Delhi that are dealing with the cancers. One is Dharamshila Cancer Institute. Second one is Rajiv Gandhi Cancer Institute, and 2 more hospitals have been involved in this study, ma'am, that we have carried out. So this is.
Okay, means doctor's consultations is there during this your
Yes,
result validations.
Yes, ma'am.
Okay.
Thank you, ma'am.
Nice. And at what percent you have received the results?
Yes,
Accuracy.
Ma'am, accuracy we have achieved around, you can say it's about 80 plus minus 10, but still we are in process of implementing the system. Actually, we are taking the help of MATLAB as well, where image classification and you can say the discrimination between the problem where occurs is the actual identification of your cancer tumor cells from the you can say beginning stages to the later on stages. Right now I have seen patients that have been you can say they have, I mean to say in tumors what basically happens is that people have perception that suppose if something has been getting irregular in your body, what we find out in India, then they don't take it seriously. And if you will go with the earlier scans of your body, then definitely it helps you to categorize it into the earlier stages where it can be prevented, because in our daily lifestyle nowadays, so cancerous is been getting the growth on growth, you can say so. So over there this work can be helpful, ma'am. What we are finding its application in future, still it's under process. So what I can say is that these are just preliminary data that we are investigating, and by your blessings and by God's grace we will definitely go on there is a long way to go, ma'am. There is a long way to go.
Yes. This is a new thing, and you are doing very nicely in this field.
Thank you, ma'am. Thank you so much, ma'am. Thank you.
Thank you.
So our last presentation is Aishwarya Girish Menon, and her paper title is Intelligent IoT-based monitoring rover for smart agriculture farming in rural areas. Aishwarya, are you there?
Yes, sir, I'm there. Just give me a moment.
So, sir, with your due permission, ma'am, can we leave the session?
You can leave if you want to listen last presentation, so you can sit.
Okay, sir. Thank you.
Is my screen visible, sir?
Yes, you can start your presentation.
Yes.
Okay. So, very good evening, ma'am and sir. I will be presenting my research paper on the topic Intelligent IoT-based monitoring rover for smart agriculture farming in rural areas. So, coming to the introduction, so for generations, ever since the agricultural revolution, human beings have actually depended on agricultural producers for sustenance and survival. And as the population increases by millions every year, a stable crop produce is essential for maintaining the livelihood of these people. And to improve the agricultural production, there's a need for a real-time monitoring system that can continuously monitor the crop health. So the proposed system actually uses three major functions. The first is soil parameter monitoring, weather monitoring, and area monitoring. So it's the same thing as I said before. So agriculture has been under extensive pressure due to man-made and natural calamities, and hence we need a real-time monitoring system in order to take care of the crop health. And this is actually something that is not there in most of the rural areas. And these people, the farmers over there, do not have enough money to buy extra labor or to buy high-end machineries to take care of their crop fields. So doing a comparative study with the existing system and the proposed system in the paper. So in the existing system, the system maintenance is actually done by actually that it's powered using cell batteries, which needs to be manually charged. And the data transfer mostly uses Wi-Fi network that's really not readily available in rural areas right now. And the data that is analyzed is actually stored into cloud servers, which is very costly and also requires fast internet connection. And most of the systems that are created are centralized monitoring systems. So this means that any of the crops that are far away from this monitoring system would give inaccurate results when you're measuring the parameters. And some of the systems are used spraying unit tanks to spray irrigation for things like that. So they have to be manually refilled each time. So in the proposed system, we are using solar panels to automate the power supply, and the data transfer is done using GSM technology. So mobile network towers are actually readily available in rural areas, and the data is stored into an SD card and the data is analyzed using a microcontroller. So there's no need of a third-party application or Wi-Fi connection. And the system performs the monitoring function separately for each of the crops. So the data will be accurate for each and every crop as it goes towards each of the crop using a GPS module. And also the filling station is separately created to automatically refill the spraying units of the system that is proposed. So coming to the working of the proposed system, here the basic construction that is shown on the right hand side. It uses an Atmega 2560 microcontroller that's placed on an Arduino Mega development board, and it uses two solar panels to power the system. So during the day uses solar energy to power the system and also to charge a lithium ion battery that will be used during the night. So the data collected will be stored and analyzed by using an SD card module, where it will be stored as a CSV text file. And other than that, the chassis of the system is rectangular in shape and it's similar to an RC car model. And it also uses continuous tracks that are found in military tanks. So it can traverse through any uneven areas. And coming to the traversal of the proposed system on the farm. So on the right hand side, I've provided a traversal path that was used by the system. So we have taken a sample of 12 crops with the geographical coordinates of each of them are pre-programmed into the microcontroller. And a magnetometer and a GPS module are used to traverse the system towards each of these crops. And this technology is actually called geotagging, and the dotted lines that you can see in the diagram over here is the path that will be followed by the system. So the system actually performs three monitoring tasks. The first one is the weather monitoring task. So in this task, it uses several sensors to sense the humidity, temperature, light intensity, and the wind speed. So this helps the farmer to ensure that if there is any extreme climatic conditions, they will be immediately alerted throughout an SMS alert. So the data analysis is done every alternate hour, and also the data will be stored to a text file for further future use. The second task is the soil monitoring task. So over here we use 5 different sensors. The pH sensor for pH sensing, soil moisture sensor for checking the amount of water, and the concentration ratio of the NPK, that is nitrogen, potassium, and phosphorus in the soil is done using NPK sensors. So the sensors are fixed onto a rotating turret for accurate measurement. And the process is done every 2 hours for this monitoring task. And also the system also uses several spraying units to spray liquids like water, insecticide, and fertilizer in accordance to the fluctuation in the soil parameters. And so, for example, you can say if the soil moisture level is low and the system detects this, it immediately starts the water spray to irrigate the crop. And lastly, we have the monitoring task for area monitoring. So area monitoring in this, the first thing that we do is the detection of fire using a flame sensor. So if it detects fire, immediately alerts the farmer and also extinguishes the fire, or it tries to extinguish the fire using the spraying unit. And the PIR sensor is used to detect the presence of any animals or human beings that may have trespassed into the crop field. And other than that, they are also using ultrasonic sensors to detect the presence of any insects near the crops. So it mainly like analyzes the communication that occurs between these insects, and it activates a piezo buzzer to hinder the communication to try and ward them off. And this is the construction of the refueling station for refueling the tanks that are present on the system. And we use Arduino Nano board for this. And the system actually sends an SMS to the main refueling station of which of the tanks needs to be refueled. So once the system comes over here using the GPS module technology, that is the geotagging technology, it immediately refuels the respective tanks using linear DC motors. So this is the flow chart of the proposed system functions, and this is a 3D model of the proposed system. Coming to the results, so for the result purpose, we have used data that is related to a tomato plant. And on the right hand side, we have the tabular visualization of the soil monitoring function. So similarly, tables will be created for the other two monitoring tasks as well. The tables will usually contain details of the crop number, crop coordinates, date and time of analysis, the soil parameter details, and if any of the parameters have fluctuated, and a rectification that was done by the system. And this will be the sample of the SMS alert that was sent to the farmers for each of the monitoring tasks. So over here we have the sample of area monitoring task. It shows that the warning that the presence of an insects were detected near the crop number P2, and it also provides the coordinates, and the rectification that is done by the system is also stated in the SMS. Similarly, the SMS is sent for weather monitoring data and as well as for soil monitoring task. So in order to understand how the system actually works, to analyze whether any of the parameters are fluctuated, I provided a graphical representation. So the blue line here represents the value of the parameters recorded for each of the crops, and the red lines represent the upper and lower ideal range within which the parameter must be in. So over here for crop number P4, you can see that it has actually exceeded the lower bounding red line. So this means that the parameter, that is the soil parameter, that is soil moisture parameter, has fluctuated to a level that could be dangerous for the plant. So the system would immediately alert the farmer using SMS that the parameter has fluctuated for crop number P4, and that it is starting the spraying unit in order to irrigate the soil. So coming to the conclusion, to address the existing system issues in the agricultural field that is essential for sustenance of human life, the automated system that is proposed in this paper continuously monitors the crop health, its surroundings, and collects the data using sensors, and also analyzes the data to provide automated solutions. And the farmer is also updated using SMS alerts with the help of GSM technology. So hence the system is self-sustainable, self-maintainable, and very cost-effective compared to the present systems in the market. And that is all. These are some of the references that I've used. And thank you. Any questions, ma'am?
So what type of hardware were used?
I'm using Arduino system, ma'am, for the microcontroller.
Arduino.
Yeah, Arduino, Mega, and the sensors that are compatible with that system, ma'am.
Okay. What is the tentative cost for this model?
It would come around approximately 15,000, ma'am. So it's much cheaper to the present day, like the systems that we have. It comes around over 1 lakh for a very good system that can monitor the crops, ma'am. So this is much cheaper compared to them.
Thank you.
Okay, thank you, ma'am.
Time for closing remarks. All presentations are done. I request Dr. Chaya Jadhav for session remarks. I am over to you.
Yes. Thank you for giving this opportunity as a session chair. Thank you for this international conference, Amit, Richa, and Jay also. So all the papers in this track were very nice, and diversity applications were there. So they are reaching to this all the areas. So thank you for choosing these papers. I hope this will be a great success. So I'm here in this as a third time session chair, and I'm seeing this improvement uh, very nicely. It is. So thank you so much. Thank you all the participants. It's a very nice interaction. Thank you, Jay. You are not audible.
I sincerely thank our
Yes.
authors for their excellent presentation and contribution in this session, and all participants for being a part of this session, interesting conference. I hope this session was informative enough. All the presenter would be getting the digital certificate through email within 2 working days. And papers are already forwarded to the Springer for publication. The publication will be live within 5 to 6 months. Kindly cooperate with the team ICTCS and SmartCom. I also thank our session chair, Dr. Chayada, for chairing this session. Ma'am, here is a token of appreciation from Team ICTCS, Global Knowledge Foundation, and SmartCom. Thank you so much for your valuable time. Now, at the last, I would like to request all to turn on their camera for good memory for this session. Aishwarya, can you turn on the camera?
Yeah, just
For
a minute,
photo.
sir.
All participants are gone.
You could have given these instructions in the beginning.
Thank you so much, all. Stay safe, take care. Thank you.
Thank you.
Yeah, thank you, sir. Thank you, ma'am.
Thank you. Shall I end the meeting?
Yes, I am.
Okay.
Thank you.